All right. Good evening, everyone. Yeah, good evening. Timiloluwa, good evening. Entertainment, good evening. Fisayo, good evening. Kende, good evening. Razak, good evening. Praise Inoluwa, good evening. Good evening, everyone. We welcome everyone back to our AI and machine learning course. Yes, so if you've been enjoying the classes so far, please just drop an emoji on the comment section. So today's class is going to be a very interactive one. Right. Duru, thank you very much. I appreciate that. Agbola, I see you. Good luck. I see you. Praise. Yes. So I'm also happy to be with everyone again this evening by the grace of God. So we'll be starting our class now. Yetunde, good evening. Adefison, good evening. Thank you very much, everyone. Thank you very much, everyone. So, okay, I think before we start, because we're going deeper from this week. This is Monday, so we'll be going deeper from this week. But before I proceed with today's topic, I would also like us to drop one or two things that you've learned so far that has been with you since the beginning of the class. So just drop one or two things that you've learned so far from either my class or the class of my colleagues so far, whether the practical class or the theoretical class. So just drop one or two things that you've learned so far and that has been with you. Yeah. So I'm also on the comment section to get our answers, our responses. One or two things that you've learned so far. Chris from Kaduna, you're welcome. Good evening. Okay, Stephen said sourcing data set. Also, sourcing data set. Yeah, so data set is very important. It's one of the is a very important tool in machine learning and artificial intelligence. So in order for you to develop your model, you need a good quality data set, to train your model. Because like I mentioned in our last class, or I think the one before the last, whatever you feed into your model, the quality of what you feed in your model will determine the quality of results you're going to get back. So garbage in, garbage out, and quality data in, quality data out. Amazing. All right. Okay, using comments in a programming standard. Awesome. Awesome. So I can see that somebody learned that somebody learned how to use comments professionally, while coding, which is also very important because comments are very good descriptions that will allow you understand, your code, to allow you understand, the things you are trying to achieve, so that when you come back to that code some other time, you can easily understand the flow. And if another person picks up that code, the person can easily understand what you mean, and the person can actually flow and continue with the process. All right, amazing. So, okay, the importance of function, beautiful. Um, no audio. Okay, I think my audio is good. Um, Summary statistics, beautiful. That's our mean, our media, our mode, and likes, beautiful. Um, Using NumPy and pandas, awesome. Importing NumPy, beautiful. All right, integer is number, float is decimal, string is oh, the comment went off. That's a very good one, actually. Very, very good one. So that's data types. We have the integer, the float, and the last one, I can't remember what the person typed. It cleared. Okay, so we have several data types, the integer, the float, the boolean, and other ones, the string. Yeah, okay, string is for alpha. Yeah, correct. Correct, that's very beautiful. The importance of data cleaning. Awesome. Awesome. I think that was our last class. So we need to clean our data before feeding them into our model. Value counts, beautiful indexing, data sourcing from cargo. I think that should be for our practical class. Yeah, so I am very sure and happy that we've been following the classes, and I'm very confident that by the end of the 3 months training, we'll come out as solid AI and machine learning students. All right, I think we should go straight into our class for today. So today we'll be discussing about creating new features, extracting dates, and binding variables. I know we've discussed about variables as containers that holds value, right? So we want to now discuss how we can create new features by extracting data and binding variables. I am Isaac Oyekule. I will be the tutor for today's session. So what is feature engineering? I'll try as much as possible to be slow, not to be fast as I'm used to. I think I got some feedback that I'm usually very fast, so I'll take it one step at a time. So, what is feature engineering? What is feature engineering? Okay, before we even go into feature engineering, what is a feature? What is engineering? Right. So we all know engineering as a common word. Engineering, fixing things, bringing things together to make it work. An input, a process, an output. You know, yeah, basically, actually. And then a feature. A feature could be like a part, a process. Yeah, in a way. So now bringing them together, feature engineering, process engineering, update engineering. Yeah, so creating new input features from your existing data to improve the model performance. We all know what our model, we've been talking about models. So models are systems, right? So creating new input features from your existing data to improve your model performance. For example, we have okay, just like our topic, we have the date of birth. For example, from our date of birth data, you can extract some information that is new features from that particular data, and that can also help improve our model performance. So let me come again. Feature engineering is creating new input features from your existing data to improve model performance. All right, so an example, just like the one I gave, you have a date of birth column. You can extract age from date of birth because you have the year, you have the month, you have the day. So you can extract your age from the date of birth column on your data set. For example, let's say we have a data set of a table of staff in an organization. For example, let's say the record of staff in the IT department. Right? So we can have your full name, we can have your email address, we can have your date of birth, we can have your phone number, right? So the date of birth column on that table, on that data set, can be re-engineered, to get new features from that particular data. So like I mentioned, you can extract age from date of birth. Yeah. Right. Another good example is you have income values. You can create income group. Income values, income group. For example, we have people that earn 50,000 to 100,000. We have people that earn 200,000 to 500,000. We have people that earn 1 million naira to 20 million naira. So we can, based on that value income, that income value, we can categorize them into groups, right? So we can extract a new feature called income group from that value, from that data. All right. So extracting features from dates. So we'll dwell on this for today. So how do we extract features from date? And like I mentioned, extracting features or feature engineering would really help us improve, would really help our model improve on its performance. Let's keep that at the back of our mind. So dates are packed with information. You can extract the year, you can extract month, you can extract day, you can extract day of the week. In fact, you can extract hours from dates. From dates, yeah. So even timestamps takes hours, takes minutes, takes seconds, right? So I know the software engineers amongst us or database engineers will understand what I'm trying to say. But in summary, we can extract this information from dates. All right, let's look at this example together. Let's say you have this column 2023, May 2nd, 14 hours, 23 minutes, and 11 seconds. So, what can we extract from this particular data? We can see we can extract the year, which is 2025. We can extract the month, which is 5, that is May. We can extract the day of the week, which is Tuesday. We can extract the hour, which is 14. So I need somebody to drop on the comment section the minutes in this our data. Let's see if we are following. So from this our data, 2023 May 2nd, 14:23 11. What is our minutes? 23. Awesome. Awesome. Beautiful. 23. Awesome. Yeah. All right. So let's move on. I'm happy that we're following. So why do we extract date components? Why? Why do we do that? So it is useful for spotting patterns. Now let's look at the patterns that can be spotted by extracting date components. So um, we can track patterns such as more orders during the weekends, higher traffic in the morning hours, sales increase in December. These are examples of patterns that can be tracked, by extracting the date component. For example, let's say we have a restaurant that sells pounded yam and egusi soup. I know some people will be smiling on the call. All right, so let's say we have a restaurant that sells pounded yam and egusi soup. So, and the order comes in via their website, for example, and this website tracks the name of the person making the order, the quantity of the pounded yam, the protein, and all those things. So now on their record, they will have this information, and then we have the timestamps. So the timestamps will hold the date and the time, right? So now, based on that information on their database, for example, let's say they have in a week, let's say they have 1,000 orders for that week. Now, out of the 1,000 orders, let's say from Friday to let's say Sunday, yes, let's say from Friday to Sunday, they have about 500 orders. And then from Monday to Thursday, they have the other 500 orders. We can see that Monday, Tuesday, Wednesday, Thursday, 4 days, they have 500 orders. But just on Friday, on Saturday, and Sunday, they have 500 orders. So they can extract that pattern that, on weekends, we have more orders compared to the weekdays. In fact, we can even say probably on Friday, on Saturday, and Sunday, they have 600 orders, right? And then on Monday, Tuesday, Wednesday, Thursday, they have 400 orders. So we can use these dates, these patterns to draw conclusions and recognize spot patterns in our data. So higher traffic in the morning hours, we can also use our date components to track when we have more traffic on our website. For example, like the restaurants that sell pounded yam, they can use the date information, the time information to know when order comes in more during the day. Is it in the morning? Is it in the afternoon? Is it in the evening? So they can use those information, that's date component, to extract all this information. So sales increase in December, this can also be gotten from the date component. Now, it makes data more understandable to machines. Extracting the date components makes data more understandable to the machines because they can also spot these patterns and connect the dots together. So I come again. Why we extract these components? Some of the reasons why is because to for useful for spotting patterns such as more orders during the weekends, higher traffic in morning hours, sales increase in December. It also makes data more understandable to machines. Yeah. All right. Examples. All right. Okay. I'm trying to also follow up with the comments in case there's something going on. All right. So, example, an e-commerce website, data column, we have the order date. So, from the order date, what are the features that we can extract? We can extract the order month. We can extract order day of the week. We can also extract the order hour. So we can also track the peak time, the low time, the months that more sales were made, and day of the week that they get more sales. So this information can actually help in it can actually help the cafeteria or the restaurant or the organization to make informed decision. For example, if I know that I have more order as a cafeteria now as a restaurant, if I know that I'll be getting more orders in the morning on a Monday morning, for example, I will make sure that we prepare more, pounded yam for Monday morning, right? So it helps the organization, it helps the restaurant, it helps the cafeteria, it helps in making informed decisions. Likewise for our model. So once we have information partitioned, well partitioned and extracted like this, it helps the model to learn better. And once the model learns better, like we said, the data should be of good quality. So these are things that makes our data of good quality. So if we have this well extracted, our model can actually learn better and perform better. In fact, some models actually do some of this extraction for it to perform maximally. Okay, examples of binding. Um, okay. I hope I've not missed something here. All right, examples of binding. So you have age as a continuous data. Okay, so before we even go to binding, I hope we understand the concept of feature engineering, extracting information, extracting a new feature from an existing data. Customer consumption pattern, beautiful, prof. Awesome. Because consumption pattern, yes, that's also very wonderful. Generative AI refers to system that generate. Okay. All right. So yeah, we're going to dwell on binding properly. I think a slide is missing. All right. So all right, so we understand the concept of data extraction and how they are very important to our model for it to perform maximally. Yeah, so I think a slide is missing here, but then I'm just going to read what we have there. So, what is binding? Before we go to the examples, what is binding? So, binding is also known as bucketing, right? It's a feature engineering technique that groups different numerical subranges into bins or buckets. Binding is a feature engineering technique, is a technique of feature engineering that groups different numerical subranges into bins and buckets. So we're going to understand that as we proceed. So let's look at this example together. You have age as a continuous variable. We have 16, we have 22, we have 35, 48, and 61. So these are age ranges and they are continuous variables. So you can bin like this. So we can say 0 to 17 is grouped as teen, 18 to 35 young adults, 36 to 60 adults, and 60 plus are seniors. So we have binned this data if that's correct. So binning is a feature engineering technique that groups different numerical subranges into bins or buckets. All right. So types of binding or binning, types of binning. So I have three types here on my screen, on my slide. We have the equal width, we have the equal frequency, and we have the custom bins. So the equal width. So we divide into equal size ranges. The equal frequency, same number of data points in each bin. We're going to look at the examples, so don't get confused. And then the custom bins based on business logic, it's e.g., age groups and likes. So now let's take the equal width. So like I mentioned, binding is just an engineering technique, a feature engineering technique actually. Is a technique for feature engineering, that groups different numerical subranges, into bins or buckets. So, like this example that I have here, we know we have the age range. So, this age range, this continuous variable, can then be grouped like this. We have the 0 to 17 as teens, 18 to 35 as young adults, 36 to 60 as adults, and 60 plus as senior. All right, so now let's take the equal width together. So, equal width divide into equal size ranges. So, for example, we have data 18 to 68, right? We have data 18 to 68. So, we can bind these numbers into different groups. For example, as the type says, equal width. So, we have a difference of 10 across all the data, all the groups. So, we have 18 to 28, we have 28 to 38, we have 38 to 48, we have 48 to 58, and we have 58 to 68. So we have grouped these numbers into a group of tens, right? So our resulting bin will be 18, 22, 27, 28 has been 1, 34 falls under bin 2, 41 and 46 falls under bin 3, 52 and 58 falls under bin 4, 61 and 67 falls under bin 5. So we're going to do an exercise quickly. I'm going to call some numbers and then we'll drop on the comment section which bin they will fall under. So the first number I would call is okay, let's start with 23. So which bin would 23 fall under? Bin 1, awesome. Mrs. Boladile, thank you very much, ma. Yes, bin 1. Jennifer said bin 2. No, bin 1. 23 falls under bin 1. 23 falls under bin 1. All right, awesome. So, okay, what bin does 40 falls under? What bin 40? Bin 3, amazing. So I'm glad we're following. So 40 falls under bin 3. All right. So types of binding, we have equal frequency binding. Okay, we discussed the equal width. Now we're going into the equal frequency. So equal frequency binding, that's the quartile binding. So each bin contains approximately the same number of data points. I repeat, for equal frequency binding, that is the quantile binding, we have each bin contains approximately the same number of data points. Let's look at an example real quick. So we have the same age data. We have 18, 22, 27, 34, 41, 46, 52, 58, 61, and 67. So 10 values, 5 bins, 2 values per bin. 10 values, 5 bins, 2 values per bin. So let's look at how that will look. So we have the sorted data. So divide every 2 entries. So we have 18 and 22. We have 27, 34, 41, 46, 52, 58, 61, and 67. So now the resulting bin, so each bin has equal frequency, 2 values. Right, so that is for the equal frequency binding. So for the custom binding, based on business logic. So for the custom binding, we use business logic to conclude or to determine this. So you create bins based on domain knowledge or specific use case. For example, we have the age groups. So we have, just like the data we had in the edition one, 18 to 67. So let's look at how it will be. So we have, excuse me, please. We have 0 to 24 as teens or young adults. We have 25 to 44 as adults, 45 to 64 as middle age, and 65 plus as seniors. So for the custom binding, we group based on logic. We group based on logic. All right, so the resulting bin will be 18 to 22 will fall under teen, 27 to 41 will fall under adult, 46 to 61 middle age, and 67 senior. All right, so practical binding example. Let's look at this together. We have an income data, 50,000, 300,000, 800,000. We have three values in our data set. So the custom bin 0 to 100K is referred to as low income, 100K to 500K medium, and then the 500K plus high income. All right, so okay, yeah. So this a practical example of the custom binding. So we have this 550,000, 300,000, and 800,000. So we have grouped 0 to 100 as low income, 100 to 500 as medium, and 500 and above as high income. So for this our data, let's say okay, so let's say this is a day. So let's say a day ends 50,000. Let's say this is Moyo. And let's say this is Ebuka. So I would like to ask, so what custom group would you place a day? So is are they earning a medium income or an high income or a low income salary? So what group would are they fall under? I want us to drop that in the comment section. Are they low income? Beautiful. And they will definitely be grouped under the low income because we have logically grouped 0 to 100,000 as low income, 100,000 to 500 as medium, and then 500 plus as high income. How about Ebuka? Would Ebuka be grouped under the medium custom bins? Ebuka, which custom bin would Ebuka be grouped under? High income, excellent, high income. So we are really following. So we've learned about binding, right, and the different types. That is the equal width, the equal frequency, and the custom bins. So this, we're talking about feature engineering and the binding, right? So this would allow us to group or to categorically group our data into different categories. We have we also discussed about extracting features from dates. We can extract a year, a month, a day, day of the week, hours, for timestamps, even minutes, seconds, and then we can and based on those information we can make informed decision, right? And discussed about feature engineering, creating new features, new input features from existing data to improve model performance. So we'll be going on a short break while we are dropping our questions. So please, if you have questions, you can drop your questions while we go on a quick short break. And then we'll be coming back to discuss outliers, very important outliers. So to really take our time, that's why I want us to go on a very quick short break, and then we'll come back to discuss about outliers. Detecting outliers, how do we handle outliers, what are outliers exactly. So we'll be coming back to discuss. While we are on the short break, you can please drop your questions so we can discuss even while we are taking a short break. Thank you. Okay, I can see some questions. Okay, okay, I'll take some of the questions now and answer them. I'm trying to scroll through. Okay, question one. Praise Inolua said, does this feature engineering help um, majorly prediction models, or it's also useful to other kinds of model? Great question. Feature engineering is is most commonly associated with improving prediction model actually, like classification and regression. But it is useful across many kinds of models, not just predictive ones. So for the predictive models now, we have like supervised learning, unsupervised learning, the reinforcement learning, anomaly detection, recommendation system. So this can also be used, for models like that. So why prediction models benefit the most, but feature engineering is a universal practice actually in machine learning and data science. So it improves the interpretability, the model efficiency, and sometimes even makes modeling possible in the first place. So it is a general, a universal practice, a general practice. Yeah. I hope that answers your question in your lower. Okay, okay, question two from Inyoluwa as well. Um, so question three, what model type is the binary mostly used for improving? Is it classification model? Yes. Binding is mostly used to improve classification models, but it can be helpful in other model types. So depending on the context, right? But basically, it is commonly used to improve classification model. So yeah, I hope that answers your question in any one. Okay, is there any question? Any other question? Uh, okay. Um, I can see another question. So, what is the difference between custom and practical binding? Are they the same? Um, they are not really the same. Custom binding and practical binding are not the same, though. They can overlap, right? But they are not practically the same. Okay. When can we use equal frequency as Alison? When can we use equal frequency and equal width binding? Okay. So equal frequency and equal width binding. So there are two common binding techniques actually, and each has its best use case depending on your data characteristics and modeling goal. So it depends on what you want to achieve, and it also depends on the characteristics of your data. So for the equal width binding, as the name implies, equal width, and then for the frequency, um, excuse me. So for the equal width, it is also called uniform binding, right? So it divides the range of a numerical variable into bins of equal sizes. That is the width. So regardless of how many data points fall into each bins, it's just categorizes ranges. It divides the range of a numerical variable into bins of the same size. You get. So, but for the equal frequency. So the equal frequency is also called, like I presented, the quantile binding, right? So it sorts the values and splits them into bins such that each bin has roughly the same number of observation. So it is more on observations, like the frequency, compared to the other one that has like the same size, right? So the equal frequency binding sorts the values and splits them into bins such that each bin has roughly the same number of observations. And we mostly use the frequency bin if you want to, balance sample sizes across bins, or maybe your data is skewed or non-uniformly distributed. That's where you can also use frequency. You can also use so if you're using models sensitive to class imbalance, you get, or maybe feature scaling, like logistic regression and the like. So you can also use that. And if you want to prevent sparse bins, right? So which can help with model generalization, then the frequency binding will be very very useful. I hope that answers your question, um, Felicia. Yeah. All right. So we'll be going into our second topic for today. All right, Felicia. Nice one. Thank you very much for that beautiful question. Thank you. All right. Moving on. Outlier detection. Outlier detection. Please a minute. Okay. Outlier detection. We have box plots, Z scores, handling outliers. So those are the three major punch lines or punch topics that we'll be taking today. Box plot, the Z scores, and handling outliers. For this second part, please, you can get your jotter and your pen. We'll be doing some little mathematics. So this is just for us to, refresh ourselves to, with these basic arithmetics. So we don't necessarily need to do them explicitly when we are coding, but having practicing them now would actually give us refresh our memory, like I said, and also give us a proper understanding where we are writing them using Python or any other programming language of our choice, right? So we'll be doing some mathematics in quotes, yeah, in today's class. All right, let's get started. What are outliers? What are outliers? I mentioned this in our last class. So they are like, okay, let's take the word outliers. So they are like the odd one out. They are the extremists, or let me say, yes. Okay, let me say the odd one out, basically. So data points that are significantly different from others. They are odd. The outliers are the odd one in the set, right? So, for example, most employers earn 50,000 to 100,000, but most employees earn, so one employee earns 1.5 million naira. All right, so that's an outlier. If we have this data set, we have, let's say we have 5 employees, for example. Let's say we have 5 employees, and then one earns 50,000, one earns 55, one earns 70,000, one earns 80,000, one earns 100,000. Okay, I said 5. Okay, let's make it 6. And then the last person earns 1.5 million naira. So you see the gap, you see the difference. So that 1.5 is the odd one, right? It is not balanced at all. It is not balanced. So that person earning 1.5, that data of 1.5 is an outlier in that data set. Okay? So why detect outliers? Why are we detecting outliers? So outliers can distort averages. Now, please, who can remind me of what finding the average of a data set is? Somebody should drop it on the comment section. Let me see the first person that would get it. So we mentioned it in our last class. If you remember, during our statistics. So exactly mean. Duru got it first. Thanks, Duru. So our average, calculating the average of our data sets, our numerical data set is the mean, right? So outliers can distort our mean. It can. Because, for example, let's imagine we have, like the example I gave, we have 6 employees, 50,000, 56, 57, 80, 60, 80, 90, and then we have 1.5. So if we're calculating the average, we'll see that because of that outlier, that 1.5, the average will be distorted compared to when we have values that are not as far, as far from each other compared to the first data set I gave, right? So outliers can distort our mean. Outliers can affect our model accuracy, right? So once an outlier is in our data and we feed that data set into a model, it will affect the accuracy of our model. And once the accuracy of our model is affected, the model won't be able to produce accurate results. The model won't be able to produce a quality result. So why do we detect outliers as well? It can also reveal data entry errors or special cases. It can help reveal data entry errors or special cases. For example, you are inputting, let's say, this is even a practical example, right? Let's say you are trying to input you remember back then in school, even in the university and even in secondary school, where some schools have this structure. They have their CA test 1, they have their CA test 2, they have their CA test 3, and they have their exam. So most schools do it like this. Their CA 1 will be over 10, CA 2 will be over 10, CA 3 will be over 10, that's 30, and the exam will be over 40, right? So let's say for a day, using a day as an example, CA 1 is scores, let's say 10 over 10, CA 2 is scores 70, CA 3 it now scores, let's say 8 over 10. So we see that CA 2 is wrong. So because we have CA 1 as let's say 10 over 10, CA 3 as 8 over 10, but CA 2 is having 70. That's an outlier and it has helped us review data entry error. Probably it's called 7 over 10 in CA test 2. But because there was an error during the entry process, we have 70. So outlier can also help us review data entry errors or special cases. All right. Outlier detection method 1. So we'll be using box plots. Box plots graphically can help us spot outliers. So example, imagine you are looking at salaries of 10 people in Naira. So the first person earns 20,000, 30,000, the second person 35,000, 40,000, 45, 50,000, 55,000, 60,000, 65,000, 300,000 respectively. Right. So we have 10 people. So that last one, 300,000, looks suspicious, obviously, right? Because we didn't even get anyone, we didn't even have anyone that ends up to 100,000 until the one of 300,000. So that is an outlier because it is the odd one out, right? So a box plot helps you all see this clearly. So the box plot helps to identify this outlier, right? So let's continue and see how the box plot helps with that. So we sort the data, we find the mean, the median, that is the middle value. So there are 10 values. Average of the fifth and the sixth gives us the median. Average of the fifth and the sixth gives us the median value. All right, so I would like us to do it together. So sort out the data. We have from 20,000 to 300,000. Sort out the data. We have 10 values and calculate the median and drop the score on the comment section. So let's see the first person that would get it. I know I've presented the answer, but let's still try it out and see that we are on the same page. So calculate the median of this data set. We have 10 people, salary from 20,000 to 300,000. So what we have to do first is to sort out the data and find the middle value. All right, Jeremiah sent 47.5, which is very correct. Ola Dimagis 47.5, Kike Lomas 47.5. All right, beautiful. So is there any other different answer? Do we have a different opinion? Dorcas 47, Martins 47, beautiful. So 47.5 is there. Yeah, 47.5. Yeah, Benjamin 40. Awesome. I'm glad we're following. So our median value is 47.5. So what we did was that we sorted the data and the fifth and the sixth value, because we have 10 values, right? So the middle numbers will be the sixth, the fifth, and the sixth value. We sum them together and find the average, which is 47.5. All right, so moving on with our box plot. So we've gotten our median. We've gotten our median, that's the middle value. Now we want to get the Q1, that's the 25% point. So finding the 25% point, middle of lower half, that's the first five. We have 20, 30, 35, 40, and 45. So finding the median of this value will be 35. So people will be wondering how we got 35. Now let's do this together. We have this as 1. We have this as 1. We have this as 2. We have this as 2. And then we have this in the middle because this data is sorted. We have 20 to 30. So we're sorting from the least to the highest. So we have 20, 30, 35, 40, 45. So we have this one goes with this one goes with this one. And then the middle number, the middle value is 35. So our middle value in this Q1, that's the 25% point, is 45. It's 35 rather, 35. So please let's take note of this. This is our Q1 at 25%. Points. Exactly. Yes, Ujo, 35K is the median. Correct. All right. So now we've gotten our We've gotten our normal media for the entire data set. We've gotten the median for the Q1. Now we want to get the median for the Q3. So Q3 is the 75% point. So we have, let's do this together. We have 50 as one. We have 300 as one. We have 55 as two. And we have 65 as two. Then we have 60 in the middle as our middle value, right? So this is for our 75%, right? So now let's say our IQR. That is the interquartile range. So calculating the IQR, we've gotten our Q1, we've gotten our Q3, we've gotten our overall median. So our IQR will be Q3, this, the 75% point, minus the 25% point. So for our, excuse me, please, for our Q3, we have 60 as our middle value. That is why we have 60 here as our Q3, that's the 75% point, Q3 middle value, right? So for 35,000, it is our Q1 middle value. All right. So we're trying to, yeah, somebody said, I thought 300 is an outlier, which is the odd one out. Why are we still considering it in our data? Beautiful question. So we are still considering it is because, so why we feel 300 is an outlier is because we've mentioned it, we've looked at it together. So what we're trying to do now is to calculate, to show evidence that truly 300 is an outlier. So we are going to consider the entire data set. Right? After processing, then we're going to determine, oh, so we are using box plot. So box plot will now tell us that, oh, after these processes that we've done, this value, from this value upward are outliers, from this value downwards are outliers. So that's what we're trying to calculate. All right, so now that we've gotten our IQR, so IQR is the Q3, the 75% point minus the 25% point, the median value of them. So the difference would be 25,000. This is our IQR. Duru, I hope I answered the question. Exactly. Awesome. All right, so our IQR now is 25,000. So find the outlier threshold. So we're going to look at the threshold now. So this is going to tell us from what point do we have an outlier. So we're going to do something together. But let's consider our lower bound, and our upper bound before we do that together. So our lower bound, we have the Q1, which is 35,000. This Q1 is this one, minus 1.5 times our IQR. Our IQR is 25. So 25 is our IQR. 25 times 1.5 will give us this. So this will give us this. So our Q1 is this 35. So our Q1 is this 35. So 35 minus 1.5 times our IQR will give us this. This is our lower bound. So anything below this minus 2.5, should I say upwards or downwards? So anything after that would be an outlier. Now let's consider the upper bound. We do Q3 Q3 is this. That's our 75% point. That's the 60,000. Then the same thing plus, so our lower bound minus our upper bound addition. So our upper bound 1.5 times the IQR will give us, so this IQR is the same as this 25. So 1.5 times 25 will still give us this, but now we are adding it to our Q3. That's our 75% point. So so 60,000 plus our IQR times 1.5 will give us 97.5 rather thousand as our upper bound. So anything above 97.5 is an outlier. So let's go back to our data. We have this, we have 20. Let's take this as A. We have 30 as B. We have 35 as C, 40 as D, 45 as E, 50 as F, 55 as G, as H, as I, as J. So we have A to J, 10 values, correct, right? So, and we've calculated that, yes, we've calculated that our lower bound is minus 2.5. Now, our lower bound okay, so our lower bound is minus 2.5. Let's take note of it together. I hope we are flowing. Okay, so our okay, so this is 2.5, so that we don't get confused. Let me write it properly. It's looking like 2.6, but this is 2.5, our lower bound. So our upper bound is 97.5. Is that correct? Yes, 97.5. All right. So if we have, so from A to J, I want us to drop on the comment section based on this now. So anything after our lower bound or after our upper bound will be an outlier. So from this data set A to J, which of them is an outlier? So just drop it on the comment section. Is it A? Is it B? Is it C? Is it D? Is it E? Is it F? Is it G? So which of them is an outlier? Faith said J, correct. Praise said J, correct. So J, which is 300,000, is an outlier because it is more than 97.5. All right, let's take K now. So let's make K a variable and let's give it a value. Let's say 96.9. And let's say L is 97.4. Let's say M is 99,000. They're all in thousand. K is equals to 96.9K. All right, so we have K as 96.9K, L as 97.4K, and M as 99K. Okay, so let's drop on the comment section which is an outlier from A to M. which is an outlier from A to M. So I want the overall data set now from A to M, which is an outlier. Okay, some people said just M. Some people are saying J and M. Okay. Okay, if you are going with only M, raise up your hand. Just use the hand emoji to signify if you are going for M. So I'll call your name before I call the other set. So we'll not choose the winner. So if M alone is an outlier, raise up your hand. Just drop the hand emoji. Okay, some people are also saying it is just J. Some people are saying it is J and M. Some people are saying it is just M. So if it is M, raise up your hand. Let's start with that. So the M gang, let's raise up our hand. Okay, I've seen one person. So if M alone is an outlier, raise up your hand. Okay, I've seen 2 people, 3 people, 4 people. Okay, 5. All right, so we have 5 people already saying M alone is an outlier because M is 99,000. So we are looking at A to M. Now we're not looking at K to M. We're looking at A to M. So we have 5 people or more that says M alone is an outlier. Okay, let's keep that aside. Now, for those that said J alone, J which is 300, they said J alone is an outlier from A to M. Raise up your hand. So the people that said J alone now, raise up your hand. Okay, we have 1, we have 2, we have 3, we have 4, we have 5. Okay, we have 5 already. So we have 5 and more people saying M alone is an outlier. We have 5 and more people saying J alone is an outlier. All right, so if M and J is an outlier, please raise up your hand. Okay. If M and J is an outlier, please raise up your hand. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, beautiful. So we know the answer already. All right, so we have J and M as our outlier. So let's look at my screen. We can see at the top, the first red letter I wrote, that is the LB, that's the lower bound. We have minus 2.5. Right? So that's our lower bound. Then our upper bound is 97.5, right? So any value after the lower bound and the upper bound, to the left and to the right, they are outliers. They are not considered to be brothers with the values that are within that range. So we have A as 20. 20 is within the range, right? 20 is not outside minus 2.5. It is not outside 97.5. So 20 is in the range, making 20 not an outlier. 30 the same, 30 is in the range, 35 is in the range, D 40 is in the range, E 45 is in the range, F 50 is in the range, G 55 is in the range, 60H is in the range, 65I is in the range, 300J, it is not in the range. Because 300 is above 97.5. Now, K is in the range because it is 69, I mean, it is 96.9. It is not above 97.5. So it is still in the range, right? So L is 97.4. It is not above 97.5. So it is still in the range. Yes, definitely, it will change. Yes, Raji, it will change, definitely. But I just gave that to make us understand, the upper bound and the lower bound. I'm not saying we should calculate the Q1 or Q3 or the IQR. We're not doing that again. We're just using this as an example to make people understand how we can identify the outliers within the data set based on the given or calculated lower bound and the upper bound. All right. So L as 97.4 is still within the range. That is the upper and the lower bound. It is still within the range. So it is not an outlier. But let's look at M. M is 99. 99 is greater than 97.5. So M is an outlier. M is an outlier. So we have, so those that raise up their hand for M and J are correct. So put your hands together for yourselves. All right. So M and J are outliers. M and J are outliers. J alone is not an outlier in this data set based on this given lower bound and upper bound. So M alone is also not. Why is Grace laughing? All right. M alone is not an outlier, but M is an outlier. J is also an outlier in this data set given the lower bound and the upper bound. Given the lower bound and the upper bound. All right. I hope you are enjoying the class. If you are enjoying the class, drop an emoji to signify. All right, everybody's clapping for it. Even those that chose M alone are still clapping. All right, beautiful. So let's proceed because of our time. Okay, so who is an outlier? Any salary below 2.5 minus 2.5K rather, not possible in this case because we don't have any value, any salary that is anybody has any minus 2.5 below, or let me say below minus 2.5 because it's not even possible, except if the person has debt in the company, right? So in our case, in this case, we don't have anybody earning that kind of salary. So, but anybody, peradventure, we have somebody earning minus 2.5 below that person, or below minus 2.5 rather, that person will be an outlier in this our data set. So any salary above 97.5 thousand, any salary above 97.5 thousand is an outlier. Is an outlier. That's why 300,000 is an outlier. Yeah, he might have taken a loan, most likely. But then we don't have such person in our data set. So let's proceed. Okay, let's take this example together. And imagine you are collecting salary data for your team. Everyone earns between 200,000, 20,000 and 65,000. I come again. Imagine you are collecting the salary data for your team, and everyone earns between 20,000 and 65,000, except one intern. So, so let's say the intern is collecting 300,000. Except one intern mistakenly entered. Okay. So let's assume the intern actually entered mistakenly the 300,000, right? So a box plot helps visualize spot that there is an error, in the input value. So a box plot would help us identify that error, that mistake, so that we don't transfer 300K to somebody that is not supposed to collect it. All right, so these things are the Intel will face the FCC. Intel are 419. All right, so to prevent EFCC from arresting them, the box plots can actually show them that, oh, there's an error that needs to be rectified. All right, so let's look at this example together. So box plot of salaries in Naira. We have 50,000, 100,000, 150,000, 200,000, 250,000, and 300,000. So we can see our 300,000 points. It's showing that there's an outlier, there's an error. But you can see the other range. That is this one, 20 to 65,000. We can see that 20 to 65,000, this is 50,000. So this, okay, let me use this. This is 50,000. This is 50,000, right? So we can have our 25K, 25K, and we have our 65K. This is 50,000, 50K. right? So we have the 50K, we have the 25K, we have the 65. So this data, we see that they are closely aligned. They are not far above the upper and the lower bound, or the lower and the upper bound. They are within that range. So we have the box plotted appropriately, but the outlier is far. So the box plot can help us identify the internal act organization payroll. Please, let's concentrate. All right. So the 300,000 is far, far to the right. So it is showing us that 300,000 is an outlier. So if we have, this is our J, if I'm not mistaken. So this is our J. So if we have our M, is 99,000. So M would be 99,000, 99,000 will be here. This is 100,000. So let's say 99,000 is here. This is also an outlier. An outlier would also be here. So an outlier would also be there. All right. So we are moving to Z score outliers. All right, we'll be going on a short break again for those who have not prepared their pen and jotter. So please, if you have not prepared your pen and jotter, do that now. We're going to be solving some mathematics now. So, all right, so you can also take your attendance. Your attendance link is on the comment section. You can take your attendance and prepare your pen and your jotter. We'll be doing some arithmetics very soon. Thank you. All right, so I hope we have our jotters and pen ready. We'll be starting in 2 minutes. In 2 minutes. Okay. All right. So if you have your pen and your jotter ready, just drop an emoji on the comment section. Let me be sure we are all together. So just drop an emoji on the comment section. So if you have your pen and your jotter with you, just drop an emoji on the comment section so that I'll be sure that we are good to go. All right, beautiful, beautiful. All right, all right, beautiful. So we'll be discussing our Z score outlier fix. We talked about the box plot and we saw how box plots can help us identify outliers. Now we will be discussing about the Z score outlier fix. Z score outlier fix. So we'll be doing some arithmetic, like I mentioned. So easy reminder. Let's say you have the following data points. We have 2, we have 4, we have 5, we have 6, we have 8. Right. So let's say these 5 values, we want to calculate the mean. So somebody should calculate the mean. You can use your jotter, your pen, calculate the mean, and drop the answer on the comment section. So let's see the first person who would get it right. Right, 5. Some people said 12.5. Some people said 5. Okay. So let's see that together. So our mean is 5. So how do we get our mean? It's our average. So we sum our values together and divide by the count. So we have 2, we have 4, we have 5, we have 6, we have 8. So 2 plus 4 plus 5 plus 6 plus 8. So the value we get, okay, let's do that together. So 2 plus 4 is 6, right? 6 plus 11 is 6 plus 5 is 11. 11 plus 6 is 17. 17 plus 8 is 25. 25 divided by 5 is 5. So we have 25. After summing everything, 25 divided by 5 is equals to 5. This is our average, which is the mean. This is our mean. So for those that got 12.5, I would really love to see how you got 12.5 so that we can correct that. But if we can't get how you got that, then this is how we got our 5 as our mean. So we summed the values together and then we divided by the count. That's 2 plus 4 plus 5 plus 6 plus 8 divided by Okay, let's say 2 is 1, 4 is 2, 5 is 3, 6 is 4, 8 is 5. That was how we got our 5. So 25 divided by that 5 is equals to 5. So that was how we got our mean. Okay, who can get our median value? What is our median value? All right, so our median is also 5, which is very correct. Okay, so what we're trying to calculate, we're going to calculate for our Z score, we need our mean, we need our sum of squared differences, and we also need our variance, and we need our standard deviation. If you remember in our last class, we mentioned that our standard deviation is the square root of our variance. If you've not forgotten, then our variance in this situation will be the sum of squared differences divided by our mean. Okay, so let's do that together, and let me draw this. We have x. We have x minus x bar, which is our mean, and then we have x minus x bar squared. All right. So so our x, we have 2, we have 4, we have 5, we have 6, we have 8, all right. So we've gotten our mean as 5, right? So what we're going to do on this next column is subtract x from our mean. So we have 2, subtract our mean from x rather, 2 minus 5. So it will give us minus 3 squared because of the minus. So we have 4. I hope we are following. 4 minus 5. 5 is our mean. So this will give us minus 1 squared. Awesome. This is 5 minus our mean, which is 5. This will give us 0 squared. This is 6 minus our mean. This will give us 1 squared. This is 8 minus 5. This will give us 3 squared. So the sum of all of this, so this would give us 9. That is 3 times 3. Minus times minus becomes plus. 3 times 3 becomes 9. This will give us minus times minus becomes plus. 1 times 1 becomes 1 plus 1. 0 squared will give us 0. 1 squared will give us 1. 3 squared will give us 9. So our sum total of x minus x bar squared will be 9 plus 1 plus 0 plus 1 plus 9, which will give us 20. So that was how we got our sum of squared differences. 20, very correct. Very correct. So if you are clear, if you're on the same page, just drop an emoji so that I'll be sure that we are good to go. And I hope we are also practicing it as I am explaining. That was why I said we should get our pen and jotter. So you can also practice this so that when you're going through the slide again, you will understand how we got all these values. All right. Thank you, Ifeoluwa. Thank you, Abiola. Thank you, Alade. Thank you, Yetunde. So yeah, we have our mean as 5. We have our sum of squared differences as 20, and then our variance. So now our variance is equals to our sum of squared differences divided by our mean. So our sum of squared differences divided by our mean will give us our variance. And our sum of squared differences is 20. Sum of squared differences is 20. So our variance is equals to 20 divided by mean, which is 5. So 20 divided by 5 is 4, because 4 times 5 is 20. So this is our variance. Four. Beautiful. I can see you, Henry. I can see you, Samuel. I can see you, Folua. I can see you, Jeremiah. Thank you very much. So our variance is 4. So who can tell us what the value of our standard deviation would be? The formula for that is, like I mentioned, is the square root of our variance. So our standard deviation. So standard deviation is equals to square root of 4, which is 2. Beautiful. Put your hands together for yourselves. Our standard deviation is 2. So we just need to understand how we get all these things and how we come about them, so that when the computer is running these things, we can say, oh, okay, it was because of this. Oh, our Z-score is this. Why is it this? What is our mean? Is there an outlier? Is there this? So all this will make us understand why we are getting that value when we are running our model. So they are very important. They are very important. You don't necessarily have to be calculating all this by then, but once you calculate it now, you understand how it works. You know what gives what. You know what needs what, right? So you'll be able to understand, the output of your model. You're able to understand the analysis that you are running. So they are very important. So our mean, to recap, our mean is 5, which is this. X bar. X bar is referred to as our mean. Our mean is that our sum of squared differences is 20. We calculated it using this table. Our variance is the sum of squared differences divided by our mean, which is 4. And then our standard deviation is the square root of 4. All right. Before we proceed, if you are clear, drop an emoji so that I'll be sure that we're on the same page. Excuse me, please. All right, awesome. I can see that we are all following. All right. Um, Okay. All right. So moving on. So the Z score Outlier fee. So imagine you have these weekly expenses. You have 2,000 naira, 2,500 for shawarma, 2,700 for biscuit, 3,000 for yogurt, and 100,000 for okay, let's say for your phone. Let's say you want to change your phone, 100,000. Okay, so imagine you have these weekly expenses. So the mean, okay, I think let's do that together. Let's calculate the mean of this value. So we have 200, 2,000, 2,000. Sorry, 2,000, 2,500, 2,700, 3,000, 100,000. So let's calculate the mean to be sure if this is correct. Yeah, I remember. So let's do that together and see if um, this mean is correct or wrong. So once you are done, just drop your answer on the comment section. Okay, let's do it together. We have 2,000 plus 25, or maybe we even do it on the table so that we can get it properly. Eraser, 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 eraser. Okay. So let's say this is our x. We have 2,000. We have 2,000. We have 2,500. Okay, you see, we are getting different values now. Some people are getting 27,200. Some people are getting 20,040. Some people are getting some people are getting okay, 2,700. So let's calculate it together. So 2,500, we have 2,700. Let's see those who are correct. 2,700 and then 3,000. By assumption, we can see the outlier already in this data set, right? But let's still go ahead. So we also have 100,000, 100,000. Okay, so what is the sum of this? Sum of x. So 2,000, yeah, 2,000 times, plus 2,000 plus 2,500 plus 2,700 plus 3,000 plus 100,000 would give us 110,200. 110, sorry. 110,200. 110,200. So this is the summation of our x, right? So let's count. We have 1, we have 2, we have 3, we have 4, we have 5. So divided by n, which is 5, will give us our mean. So this divided by n is 5. will give us 22,040. 22,040 as our mean. So for those who sent in 2040, they are very correct, 100%. All right. So our standard deviation. Okay, let's somebody calculate the standard deviation and send to the group. So let's see if this is this is correct. So let's see if this is right or wrong. So let's do it together, please. So what is the standard deviation? Remember, our standard deviation is the square root of our variance, and it is also, and our variance is the sum of square differences divided by our mean. So if our mean is this, it will be 2000 minus this squared. So let's say this will be x minus x uh, squared. So 2000, let's do it together. 2000 minus 22,040 will give us minus 20,040. Then we square it. Two thousand and 40. Okay, nobody has dropped it yet. So let me continue. So here is the value is very long, but let me see. 401,601,600. Then 2,500 minus 22,040. We have minus 19,540 squared. We have 381,811,600. Okay, let's do this together. So 2,700 minus 22,040 squared. What's the answer? Somebody should drop it, so we'll just continue together so that everybody is carried along. I would also do it on my end. 2,700 minus 22,040. I have minus 19,340, then squared. We have 374,000. We have 374,000. Yes, then we square it, Sarah. I'm sorry, Yetunde, we square it. Yes, 374,000, 74 million, sorry, and 35,600. 600. Okay. Then we move to the next. No, it will not be minus again. It will be positive because we squared, right? So x minus mean, all in brackets squared. So multiplication, we cross out the other multiplication. Minus times minus become plus. So let's do that for 3,000. So 3,000 minus 3,000 minus 22,040 That is minus 19,040 times minus 19,040. So that's the square, right? If you want to square it, it has to be in the bracket. So we have 362 million, 521,600. Then, lastly, we have 100,000 minus 20,000, 22,040. We have 77,960 squared. 77,960. We have 6 billion. Is that 100,000 minus 22,040, 1,960. So we have 6,000,000. Is that 6,000,007? Okay, so if we sum all of this together, okay, let me do that, plus 3. I hope this my calculator is giving me the correct thing, but let's continue. 600 plus 374035 600 plus 381,811 600 plus 401,60. I hope we're on the right path though. 600 divided by 22,000, our mean, and 40. So we have, I think there's an error. I am getting 344,000. Oh, there's an error somewhere. Oh, yes, there's an error. These our values are too big. I was also wondering. So the problem is that 2,000 minus this cannot give us this. So it is wrong. I think there's a problem somewhere. I think that should be from my end. So sorry. Apologies. I noticed it, but I was just thinking we're still on the right track. It can never be this. So I think I should just use. Instead of using calculator. So 2,000 minus this will give us 20,040. Let's just use our head. So this will give us 20,040. I want to catch up in time. 20,040 squared. Oh, it will actually. It will. Okay, I want us to do it. It will actually because of the square. So I want us to calculate this standard deviation to be sure. So what we're going to do is maybe what's the time? 15 minutes more. Okay, so we have 43,136 here as our standard deviation. That's after performing. Oh yes. That can be very correct because we'll find the square root of this. We'll find the square root. Yes, this can be very correct. So, so after getting the variance, right? We'll now square root our answer. Yes, standard deviation will be the square root of the variance. So to calculate the variance now, we have to complete this, right? And then we divide it by our mean. So after dividing by our mean, we will now find the square root of our answer. That will now be our standard deviation. Yes, 344,724.6 dot 6824 was what I also got. Then we'll find the square root of that. So for our Z score of 100,000, so 100,000 minus our mean, right? 100,000 minus our mean, okay, 43,159.47. Awesome, that is correct. So Mr. Adeleke Adebayo is correct. So this standard deviation is correct. So we'll now, to get our Z score of the 100,000 will now be 100,000 minus our mean, all divided by our standard deviation. So we got approximately 1.78 as our Z score. Okay, let's proceed. So if Z score is greater than 3 or lesser than 3, it is an outlier. Our Z score here is 1.78. So if Z score is greater than 3 or lesser than minus 3, then it's an outlier. So because we got Z score as 1.78, our Z score is 1.78. It is not above 3, so it is not an outlier. 100,000 is actually not an outlier. So since 1.78 is less than 3, 100,000 is not flagged. But if the value were even higher, that is 200,000, it would be. So looking at this value now using Z score, this 100,000 is looking odd actually. But after calculating the Z score of our 100,000, we saw that it was still within the range. It was not above 3. So using this condition of our Z score greater than 3 or less than minus 3, then 100,000 is not an outlier. It is not flagged. So that will be the end of our today's session. We've talked about feature engineering. We talked about how we can extract features or information from our existing data. We also talked about identifying outliers. We talked about the getting the upper bound and lower bound and ensuring that our values aligns and they are not out of bound, because once they are out of bound, they become an outlier. We discussed about the box plot. We discussed about the Z score. We also did some mathematics. We calculated the mean, the median, the mode, and the likes. All right. So, that will be the end of our class today. But we're not just going now. I would also like us to drop some questions. Yes, 20,040 is correct actually for the mean. It is very correct. We did that together. So if you have questions as regards from the first topic or the second topic, you can drop them, we review them, and then we call it a session today. And if you also enjoyed the class, please let me know on the comment section, and feel free to reach out to me. I think they dropped my LinkedIn and Instagram, and do well to reach out for if you're calculating some things that are getting some errors or something. Feel free to reach out, and we can grow together and build ourselves. So feel free. So if you have any question, please let us discuss. Let us discuss. Okay. I can see a question. I did not receive any mail. Okay. Um, so please explain IQR again. Okay. So IQR, we used IQR in our box plot calculation. So IQR is the interquartile range, right? Is a measure of the statistical dispersion. So it tells you how spread, the middle 50% of the data is, right? So an IQR, the formula for IQR is the Q3 minus Q1. That is the 75% point minus the 25% point. Yeah. So that's just QR basically. It's the range of the middle 50% of the data. Shikina. I hope that answers your question, Timileyin. I love this class. Your classes. Thank you very much. Thank you very much. So you can also follow me on social media. We can always communicate and we can learn together. Um, which is better, the box plot or the Z score? Anyway, it depends on the characteristics of your data actually, but any of them is fine. But me personally, I think I would prefer the box plot. I can just write a function, a Python function that can help me um, design or develop a box plot based on my data. So just seeing it visually, I can tell that, oh, there's an outlier on my data. There's an outlier in my data that I need to fix and things like that. So I personally would prefer the box plot, but then it still depends, it still boils down to the characteristics of the data set. Um, I have a question. Doesn't the lower bound and the upper bound change due to need? Definitely, it will change. That is if you are calculating it again. If you put in more values, it will definitely change. But we didn't change it in our this because I was trying to just explain if we understood which one and which one is not, in that range, to identify the outlier. So I just use that as an example. But ideally, once you add new values, you definitely have to calculate so that because those values, your upper bound and your lower bound will definitely change. Will definitely change. Yeah, thank you, Mr. Timlane. Okay, the 100. Okay, let me go back to that. Keep. Okay, so for this Z score, we have this condition. If Z score is greater than 3 or lesser than minus 3, it is an outlier, right? So, and we got a Z score of 1.78. Oh, it's going back. 1.78. So, since 1.78 is lesser than 3, 100,000 is not flagged because the we calculated the Z score of this of 100,000. So, 100,000 minus the mean divided by the standard deviation will give us the Z score for 100,000, right? So if you calculate the Z score for 2,000 now, to be 2,000 minus 22,040 divided by for 3,136. So you get the Z score for this. And if the Z score is within this range, that is Z score is greater than 3 or lesser than minus 3. If it is within the range, it is not flagged as well. But if it is outside, it is flagged. It is an outlier, right? So that's how it works. Definitely, yes. You can do all this calculation using Python. Definitely. So probably I will touch base with our other instructors. So on Friday, I should do some practicals as regards this on Friday. You should. So come prepared and come with your fingers being active. Come with your active fingers. Yep. Um, okay. So it's 5 minutes to 9. Um, we'll call it a day from here. And then I hope to meet everyone again next week by the grace of God. Enjoy yourselves, enjoy the rest of your day, and if possible, revise what you've learned today and prepare against your next class on Wednesday. Thank you very much, everyone. See you next week. I remain Isaac Oyekule. You can follow me on Instagram and LinkedIn. Thank you. Bye, everyone. Yeah, thank you very much, Mrs. Yetunde. Thank you. Thank you, Mr. Olaruwaju. Thank you, Mr. Julius. Thank you, Eddie. Thank you, Praise. Thank you, Mr. Antleke. AI to the world. Yeah. Right. Yeah. Thank you, Miss Ukali. Sorry if I pronounced that wrongly. Mr. Steven, thank you. Yeah, for the squad, please you can contact the admin. They will direct you accordingly, please. Right. Bye, guys.